Hello and welcome to the Unit 8 Section 4 video on transformations of quadratics. So what we're going to talk about in this section is how can we create quadratic functions off of the simplest type of function that we have. And the simplest function that we have of any type of function, and quadratics being included in that, is a parent function. The parent function is the simplest function with the defining characteristics of the family. So a quadratic parent function is f of x equals x squared, or you can just simply say y equals x squared. To be a quadratic, you have to have the x squared term, and the squared term has to be the highest exponent that you have. So y equals x squared is the simplest form of a function that meets those requirements. Any quadratic function with a different rate of change, a vertex other than the origin, and or opens downward is simply a transformation of that parent function, y equals x squared. Now, recall the vertex form of the quadratic equation. F of x equals a times the quantity x minus h squared plus k. It is the vertex form because you can read the vertex as being h, k. Those are the coordinates of the vertex. And x equals h gives us the location of the axis of symmetry. We can take this form and talk about the type of transformations that we have. So the first obvious place to start is with the vertex. We know that the vertex is hk. Those are the coordinates of our vertex. H is the x-coordinate of our vertex. So h tells us how much we have moved left or right. That's the first two items in this table, is how much have we moved to the left and how much have we moved to the right. And that is going to be based as to whether or not h is positive or negative. So an example of these is if h is positive, you'll have something like x minus 3 quantity squared. The 3 itself is positive. I know there's a minus sign in front of it, but if you look back at the form has a minus sign in it. So the 3 that follows that minus sign is positive in itself. Let's look at what a translation to the left is. That's when h is negative. So if we make h negative, make it say negative 3, now that negative 3 follows a minus sign. And we know that a negative, if we have a minus, a negative, that's going to give us a positive. So it's going to look positive in the form. So if it looks positive, you're going to the left. If it looks negative, you're going to the right. The k value is our y value of our vertex, and that is going to tell us if we're going up or down. And this is much easier to follow. It's simply after the square, the number that follows. So if it's positive, such as plus 5, we're going up. Here we're going up 5 units. If it's negative, we're going down those 5 units. Now let's talk about a reflection across the x and y axis. Now, if a is negative, which is our outside term here, then we have a reflection across the x-axis, which means we switch from being concave up to concave down. So an example of that is if you have the negative in front of the x squared. Now, a reflection across the y-axis is when x is negative, which means the x would have to be negative before you square it. If this is the case in a quadratic, that parabola gets flipped and it's still going to look the same. Okay? If you flip it upside down across the x, of course that makes a change, but if you flip it along its axis of symmetry, it's going to look the same because it is symmetrical. So we're not going to be that concerned about reflection across the y-axis in a quadratic function. You'll see this come into play more in something, say, like a cubic function or higher order polynomials and a couple of other different function types, such as a radical function. And we'll talk more about those in Algebra 2. All right, we have one more piece of information that we get from the A. So the A being negative or positive tells us if we're reflected or not across the x-axis. The value for the A tells us if we're stretched or compressed. So if A is greater than 1, then we're going to be stretched. So if you have, say, a number like 2 or 3, or say 3/2, because that's a fraction, but it's still greater than 1, then you're going to be stretched. If a is somewhere between 0 and 1, say a half, a third, a fourth, 3/4, anything that's less than 1, then it is compressed. So there's an example of what that looks like. So let's identify some transformations, starting off by looking at the graphs themselves. So in A, we have translated the vertex to the left or to the right by 2 units, and we have translated it down by 3 units. Okay, and that's all that's happening here. Now for B, the first obvious thing is we have reflected it across the x-axis. That means the A term is going to be negative in this case. We also have compressed it because if you look closely, let's count how many grid boxes we go over and up to still hit the function. So in the parent function, from the vertex, we go over 1 and up 1, and we're back on the graph again. If we look at the reflected one, our transform function, if we go over 1, we end up going up a half. And that means that we are compressed. Our y is not going up as quickly as it was in the parent function. So therefore, we are compressed vertically. Here in C, we have a translation up, but we also have a stretch because, again, if you count the over 1, up 1 that we have in our parent function, here in the transformed one, we go over 1 and up 1, 2, 3. So it is vertically stretched, and then it is also translated up 3 units. And then for D, we have reflected our parabola, and we have shifted to the left 3 units. So that's how we do it looking at a graph visually. We can also identify transformations by looking at what's happening in the equation. So here we're going to be looking at our A, our H, and our K. So first of all, in example A here, we have an A term of 3. That's greater than 1, so we are vertically stretched. In B, we have an H value of 2. It is positive 2 because it follows the minus sign, so we are going to the right. And then the plus 3 on the end tells us we're going up 3 units. For C, we have a negative out front. If you have a negative out front, we are reflected. And then the plus 5 on the inside tells us we're going left 5 units. For D, we have a negative out front, so we are reflected across the x-axis. We have a 2. 2 is greater than 1. That's our A value, so that's a stretch of 2. And then we have a plus 1 after our square term, so that's up 1 unit. For E, we have a 1/4 out front. Our A is less than 1, so we are compressed. We also have a H value of 3, and it follows a minus, so we're going to the right 3 units. And then finally, we have a minus 6 on the end, so we're going down 6 units. And then for F, we have a value of 1/2, so we are compressed by a factor of a half. And then we have a minus 2 on the end, which means we're going down 2 units. The other topic I want to cover in this section to finish things off is writing a quadratic function given a graph. So we're going to be able to take a graph and look at the parabola on it, and we're going to be able to write the equation for it, and we won't need technology for it or anything like that. So to do this, first you're going to identify the coordinates of the vertex and some other point on the parabola. Those are the 2 pieces of information you're going to need. Then we're going to plug in the vertex for H and K and the point for X and Y. The only thing that we won't be plugging in is our A. We're going to solve for A. That's the 3rd step. And then you're going to, once you have A, plug A, H, and K back in to the vertex form without the point plugged in for X and Y. And that's going to give you the equation for the function. Because for the equation of the function, you need to have something with X and Y in it. So let's take a look at a few examples. So for part A of example 3, we are going to need the vertex and the point. So if we look at the vertex, we go over 1, down 2. So the vertex is at 1, -2. And then we're going to pick a point. So I'm going to pick 3, 2. Okay, that's a point on the parabola. And we're going to plug those things into vertex form. So in place of y, we're going to put 2. In place of x, we're going to put 3. That's from our point. In place of h, we put 1. And in place of k, we put -2. And so then we go and solve. 3 minus 1 is 2. We go ahead and make this -2 on the end. 2 squared is 4, so we got 4a. Add 2 to each side, and then divide by 4, and we get a equals 1. Now that we have our value for 1 for a, we're going to write our equation. Y equals, your a value would go here, but since it's only 1, we don't have to write that. X minus 1, that's our h, squared minus 2, which is our k. So this is the equation for this graph. All right, let's take a look at another example. For B, again, we're going to need the vertex and a point. So our vertex is on the x-axis, so it's at -3, 0. And let's pick a point. Let's say -5, -4. Okay, so that's right here. That is a point on our parabola. You can pick another point if you would like, but that's the one we're going to use here. Then we're going to take our vertex form, plug in our x and y, and our h and k. The h and k from the vertex, the x and y from the point. So when we do that, we get this, and then we clean up a little bit. So on the inside of our parentheses, we're going to have -5 plus 3. We're going to drop the plus 0 in the end because we really don't need that. -5 plus 3 gives us -2. -2 squared gives us 4. And then if we divide each side by 4, we get a is equal to -1. So now we're going to plug in -1 for a, -3 for h, and 0 for k, and that gives us this equation. All right, let's take a look at C. Again, we need the vertex and a point. Our vertex is at 0, 0. And let's say 1, 2 is a good point to use. The vertex being at 0, 0 is going to make this fairly easy to work with because 0 is going to go in for our h and our k. So we put 2 in for our y, 1 in for our x, and then the 0 and 0 go in for h and k. So that's just going to leave us with 1 squared, which is just 1. So that's just 2 equals a. So we've got our a value. We're going to plug that back in. Y equals 2. And then we've got no h and no k, so we're just left with the x squared. So that's our equation for that graph. And then finally for D, we need our vertex, we need our point. Our vertex is at the y-intercept, 0, 3. And we're going to use the point 1, 2 again, because that is on the parabola. So plug in 2 for y, 1 for x, 0 for h, 3 for k. So in the parentheses, we just have 1 squared. 1 squared is just 1. Subtract 3 from each side, and we get a equals -1. Plug -1 in for a, plug in 0 for h, and 3 for k, and you get -x squared plus 3. All right, so that finishes off this section and this unit on quadratics.